All right, so today we're going to be diving into some really cutting-edge AI research,
Yeah.
stuff that has really big implications for anyone that is building agents that need to operate in really dynamic environments. We're talking about like long horizon reasoning and decision making.
Mm.
Think of like complex actions and decisions that play out over extended periods of time, not just quick little things.
Right.
For this deep dive, we've got this fascinating paper hot off the archive press. It's called BALROG, Benchmarking Agentic LLM and VLM Reasoning on Games.
So what's fascinating to me about Balrog is that it goes beyond just evaluating, simple tasks. It really tries to tackle this question that often gets overlooked,
Yeah.
which is, are current LLMs and VLMs truly agentic? Can they act intelligently in these complex situations and not just follow instructions in a static environment?
Right. And why is that distinction so important? I mean,
Right.
especially for AI engineers and researchers who are, really pushing the boundaries of what's possible with these models.
Well, because we need to be honest about where AI, excels and where it falls short.
Mm.
The paper itself states that, and I'm quoting here, LLMs possess vast knowledge across domains, can reason in specific scenarios, and can reliably follow human instructions in simple settings.
Okay.
These abilities suggest that LLMs have the potential to become efficient agents.
Okay. So the potential is there, but where are we falling short?
This paper goes on to highlight the challenges.
Right.
And it states that state-of-the-art models continue to exhibit persistent failure modes on many of the skills that are crucial for autonomous real-world interaction.
Okay.
Skills such as, and I'm quoting again here, acting robustly in dynamic environments, learning from mistakes, reasoning about space and time, and planning over long time horizons. These aren't just like theoretical nice-to-haves. These are like fundamental things, right, to building agents that can operate effectively in the real world.
Absolutely. And that's where BALROG comes in.
Yeah.
It's designed to test these crucial abilities using something that I think we all know and love, and that's games.
Exactly. And games have always been a really powerful tool in AI research. They offer these structured environments with clear goals,
Mm-hmm.
which allow us to measure progress in a more controlled setting.
Yeah.
What sets Balrog apart, though, is its focus on these long horizon tasks, the ones that require planning, adaptation, decision-making over these extended periods.
Mm.
It's not about instant gratification.
Right.
It's about thinking strategically and how you execute those strategies.
Right. It's like how do you make a plan and then stick to it for a long period of time?
Yeah.
Okay, so game on. What kind of games are we talking about here?
So Balrog actually uses a suite of 6 games, each carefully selected to kind of test, different agentic abilities. We've got a good mix of complexity here. We've got, starting with Baby AI, which is a simple grid world environment.
Uh-huh.
And this is a good baseline for testing basic instruction following. Can the AI understand natural language commands and actually execute them in this straightforward setting?
So baby AI is like the AI equivalent of like learning to walk before you can run.
Precisely. And then we step things up with a game called Crafter.
Okay.
It's a Minecraft-esque world that focuses on survival. So here the AI needs to actually gather resources, craft tools, potentially even engage in combat.
Oh, wow.
This introduces elements of resource management, planning, adaptation to changing circumstances, all skills that are really essential for any agent that's operating in a dynamic world.
Right. So from basic instructions to survival mode, what else is on the menu?
Well, next up we have Text World, which is all about language processing. Imagine, like a classic text adventure game. No visuals, just descriptions of locations, objects, and actions. Can the AI navigate this world solely through language, understanding the nuances of text and making decisions based on its interpretation?
Right. So that's a great test of like pure language comprehension and reasoning. It's like the AI is reading a book and it's trying to figure out what happens next.
Exactly. Then things get really interesting with a game called Baba Is You.
Baba is you.
Baba Is You. This is a popular puzzle game where the rules of the game themselves can be changed by the player.
Oh, wow.
So it's a fantastic test of dynamic reasoning. Can the AI adapt to these shifting rules, understanding how changing one element impacts the entire system?
Wow.
This requires a level of, cognitive flexibility that goes beyond just simply following pre-programmed instructions.
Right. Okay.
No.
Baba is you sounds like a real brain twister, even for humans.
Yeah.
What else does BALROG throw at these AI agents?
Well, then we've got Mini Hack, which is based on the notoriously difficult NetHack, but it allows researchers to design custom tasks within that environment.
Okay.
So think mazes, think quests, even a Box-O-Band-like puzzle.
Hello?
It's a really versatile testing ground for assessing, a wide range of skills: exploration, navigation, long-term planning, resource management, even combat. Mini-Hack is where we start to really push the limits of agentic AI.
Okay, so it's like an obstacle course designed to challenge like every aspect of the AI's abilities. And finally, the main event, NetHack itself.
NetHack, the granddaddy of roguelike games, infamous for its difficulty and complexity.
I've heard about NetHack, and yeah, it's not for the faint of heart.
No. We're talking sparse rewards, long-term planning, tons of randomness, this vast world to explore, permadeath, a true test of mettle, even for like seasoned human players.
Wow.
And to make things even more challenging, the paper emphasizes that all these environments are procedurally generated.
Okay, so they're not the same every time.
Right. So the AI can't just memorize solutions. It actually has to, generalize its knowledge and apply it to these, novel situations.
It's got to be able to think on its feet.
Exactly. BALROG is all about testing the AI's ability to handle the unexpected, to, think on its feet, to adapt and learn in these dynamic, ever-changing environments. And the paper focuses on zero-shot performance, meaning the models are tested right out of the box, no fine-tuning for these specific tasks.
So, like, no cheat sheets,
Yeah.
no special training, just the AI's raw abilities put to the test. So how did they do?
Well, that's what we'll delve into next. The results are quite revealing, I think. They highlight both the potential of these models, but also, the significant hurdles that still lie ahead in this quest for true agentic AI.
All right, so let's take a quick break, and when we come back, we'll dive into those results and see what they tell us about the future of AI.
Welcome back. Before the break, we were talking about this immense potential of LLMs and VLMs to become truly agentic. But as this new research reveals, there are still some significant hurdles to overcome.
Right. We saw how BALROG kind of throws these models into a gauntlet of increasingly complex games, testing their abilities in areas like spatial reasoning, exploration, long-term planning. But the big question is, how did they do? How did they fare?
Well, let's start with the good news, I guess you could say.
Okay.
The paper states that most leading models demonstrate fair average progression on Baby AI, Crafter, and Baba is you. So in these simpler environments, they show some promise.
Okay.
But as the challenges ramp up, we start to see the cracks.
Okay, so let's unpack those results a bit. What specific insights can we, kind of glean from the performance on each game? What should AI engineers and researchers be paying close attention to?
Right. Well, let's start with Baby AI, which, as we discussed, is really, more of a baseline test.
Right.
Even here, where the tasks are relatively straightforward, there were some interesting observations. The paper notes that, and I'm quoting here, "We observed significant shortcomings in the agent's ability to place objects adjacent to other objects, which is required in some scenarios."
So even in a like simple grid world, we're already seeing limitations in spatial reasoning. It's not just about like understanding instructions. It's about understanding like the spatial relationships between objects and how actions impact, those relationships.
Precisely. And this becomes even more apparent, I think, as we move to Crafter, where the AI needs to navigate this more complex, three-dimensional world.
Right.
In this environment, GPT-4o, a leading LLM, performed, quite well in language-only mode. However, its performance actually dropped when given visual information.
Wait, so the model did worse when it could see.
Yeah.
That seems counterintuitive. Shouldn't the visual input have helped?
You think so, right. But this finding actually aligns with, a broader trend that was observed across the study.
Okay.
VLMs, they often struggle to effectively utilize, visual information. The paper states that, and I'm quoting again, "Current multimodal transformer architectures are still better equipped at handling textual information than visual input."
So even though like these models are designed to process both text and images, they haven't quite mastered the art of visual reasoning. Like they're still learning to see the world, understand like the meaning behind the pixels.
Exactly. And this is a significant challenge because, for a lot of real world applications, the ability to, process and interpret visual information is crucial. Think about self-driving cars, robots navigating complex environments, even, AI systems designed to assist with medical diagnoses.
Right. It's a reminder that we can't just assume that more information, in this case visual input, will automatically lead to better performance. It's about how effectively the AI can integrate and utilize different modalities of information.
Absolutely. And this is where things get really interesting. The study found that different models, exhibited varying levels of proficiency in handling visual input.
Yeah.
For example, Gemini 1.5 Pro, another leading model, actually performed better in Crafter when given both text and images.
So it's not a universal weakness. Some models are better at this than others. What does that tell us about the differences in architecture or training methods?
Yeah, that's a great question. It's one that, researchers are actively exploring. What is clear, though, is that simply scaling up model size, isn't the solution. The study found that, quote, Llama 3.2 90B performance decreases very sharply when images are added, getting worse average progress than its smaller 11B model.
So bigger isn't always better. It's about finding the right balance between model complexity and the ability to actually process and integrate different types of information.
Right. Now, shifting gears a bit to text world, where a focus is, purely on language processing.
Okay.
Here we see, a different set of strengths and weaknesses emerge. In this domain, GPT-4 and Claude 3.5 Sonnet, both powerful LLMs, were kind of the top performers.
Okay, so when it comes to like pure language comprehension and reasoning, these models are showing real proficiency.
However, there were some interesting observations here as well.
Yeah.
The study found that the Gemini models, quote, fail to complete any tasks being flagged as unsafe by the Google Gemini API, despite the prompts containing no actual safety concerns.
That's a curious finding.
Yeah.
It suggests that there might be some like oversensitivity in the safety protocols for those models, potentially hindering their ability to explore and learn in these environments.
Right. It highlights, a tension that we need to navigate carefully
Yeah.
as we develop these increasingly powerful AI systems. Finding the right balance between safety and exploration.
Mm.
We want to ensure that AI systems operate within ethical boundaries, but we also want to allow them the freedom to learn and adapt.
It's a reminder that AI development is not just about technical prowess. It's about navigating these complex ethical considerations as well.
Absolutely. Now, moving on to the the game that really puts dynamic reasoning to the test, Baba Is You.
Right.
What's fascinating here is that the Llama models, they actually outperform GPT-4o in this environment. In fact, Llama 3.2 90B achieved a score that was 10% higher than GPT-4o in the language-only mode.
So Llama seems to have an edge when it comes to this kind of rule-based reasoning, where the rules themselves are constantly changing. That's a valuable insight for anyone working on AI systems that need to operate in highly dynamic environments.
It is. However, it is important to note that once again, the performance of most models declined when visual information was added, that recurring visual reasoning hurdle.
Right, right. Okay, so we've seen how these models, kind of fare in the simpler environments, but now it's time to face the real challenges: mini hack and net hack. These are the games where we truly see the limitations of current AI systems.
Exactly. And the results are, shall we say, humbling.
Let's start with mini hack. What happened when the AI was kind of thrown into this obstacle course of agentic challenges?
Well, even the most advanced models really struggled. GPT-4o and Gemini 1.5 Pro, performed the best, but even they only managed to complete some of the simpler tasks, like navigating corridors.
Okay.
When it came to the more complex challenges, like the quest and Boxoban puzzles, the paper states that, quote, none of the models solved any task in those categories.
Wow. So not even a single successful completion.
Right.
That's a stark reminder of how how far we still have to go, in developing AI systems that can handle like complex multi-step tasks that require, long-term planning and strategic decision making.
And if those results were humbling, the performance on NetHack was downright eye-opening. The paper bluntly states that, quote, all models flatline with NetHack.
Wow.
With the best performing model, OpenAI's O1 preview, achieving an average game progression of just 1.5%.
So essentially, they barely scratched the surface of this complex and challenging game.
Right. The authors highlight that, quote, the best individual run was achieved by Gemini 1.5 Pro Vision Language Mode, reaching Dungeon Level 3 and Experience Level 4. But to put that in perspective, NetHack has dozens of dungeon levels, this, vast, intricate world to explore.
Right.
Reaching level 3 is like taking a few baby steps in a marathon.
It really underscores the gap between, the current capabilities of AI and the level of like mastery that's required to excel in a game as demanding as NetHack.
And it's not just about, gaming, right? These results have broader implications for the development of agentic AI systems in general. If our, most advanced models are struggling to navigate a, relatively well-defined environment like NetHack, it raises questions about their ability to handle, the complexities of the real world.
And this is where it gets really thought-provoking, right? We often talk about AI, solving real-world problems, driving cars, managing resources, making complex decisions. But if they can't even, conquer a game, how can we trust them with those real-world tasks?
That's the million-dollar question, and one that I think BALROG forces us to confront head-on.
Yeah.
It's a wake-up call, I think, for the field, a reminder that we need to be both ambitious and realistic in our expectations.
So where do we go from here? What can AI engineers and researchers, kind of take away from these findings to guide their work? Is there hope for improvement?
Well, that's what we'll explore in the final part of our deep dive. BALROG might expose the limitations of current AI systems, but it also offers, I think, some valuable insights and potential paths forward.
So we've spent the last two segments really digging into this BALROG benchmark, how it pushes these AI agents to their limits.
Right.
And where those limits, currently lie. And it's been a pretty humbling, look at the state of agentic AI. But now I'm curious, like, what does it all mean? Like, if AI is struggling with even a game like NetHack, where do we go from here?
Yeah, that is the crucial question. And honestly, I think it's exciting. BALROG isn't just about exposing these weaknesses.
Right.
It's about providing, this roadmap for future research and development.
Okay.
By identifying these specific areas where AI struggles, it gives us, this clear target for improvement.
So it's like a challenge. It's a gauntlet, thrown down for the entire AI community.
Exactly. And the paper itself, it points to some promising directions.
Okay.
Remember how we talked about the AI's difficulty with long-term planning, breaking down these complex tasks? Well, the authors suggest that, these advanced reasoning strategies, might hold the key to overcoming these hurdles.
Okay. So remind us, what are those strategies and why might they make a difference?
Sure. So they specifically mention techniques like chain of thought prompting, self-refinement, and basic planning. These approaches have already shown some promise in improving performance on shorter context tasks.
Okay.
And the authors believe that they could be adapted for these long horizon challenges that are presented in BALROG.
Okay. So let's kind of break those down a bit. Chain of thought prompting. What's the thinking behind that?
So it's based on the idea that, if we can encourage the AI to kind of articulate its reasoning process, to think step by step, it might be able to tackle these more complex problems. So instead of just spitting out an action, it would walk through its thought process, right, making its decisions more transparent and potentially more effective.
So it's like giving the AI, like a whiteboard to kind of work out its ideas before committing to an action.
Yeah, exactly.
And you mentioned that this approach has already shown some success.
It has. The paper highlights that, OpenAI's O1 model, which
Hmm.
has, these chain of thought capabilities, it performed significantly better on NetHack than other models.
Okay.
It wasn't a, dramatic victory by any means,
Right.
but it does suggest that, this line of research is worth pursuing.
Okay. Oh, what about self-refinement? How could that help, AI agents become more agentic?
So self-refinement is all about giving the AI the ability to learn from its mistakes.
Okay.
It's like having this built-in editor that's constantly checking and refining, the AI's work. So imagine an AI, playing NetHack. It makes a mistake, but then it's able to analyze that mistake and adjust its strategy accordingly.
Right. So it's like the AI, becoming its own coach, constantly reviewing, its performance and looking for ways to improve.
Exactly. And then there's basic planning, which might seem obvious, but it's something that current AI models, still struggle with, especially when faced with these long horizon tasks. The ability to break down this complex goal into smaller, manageable steps, to anticipate future challenges and to adjust plans on the fly. These are all essential components of true agency.
It's like the difference between, wandering aimlessly through a maze versus having, a map and a compass to guide your way.
Precisely. And the authors of the BALROG paper, they believe that by incorporating these advanced reasoning strategies into the training and development of AI agents, we can make significant strides towards achieving true agency.
But it's not just about, you know, fancy algorithms and training techniques, is it? We also need, the right tools to evaluate and benchmark these advancements.
Absolutely, and that's another key contribution of Balrog. It's not just a set of challenges; it's this open source toolkit and standardized evaluation framework that anyone can use.
Okay.
This allows researchers to compare different models, to track progress over time and to identify the most promising approaches.
So it's like creating, a common language and a shared set of standards for the field of agentic AI research.
Precisely. And the authors explicitly encourage, the AI community to embrace Balrog,
Okay.
stating that, and I'm quoting here, "We hope that Balrog will not only serve as a useful benchmark for agentic reasoning, but also facilitate the development of novel agents and techniques to address its challenges."
So it's a call to action. It's an invitation to collaborate and to push the boundaries of what AI can achieve.
And it's not just about academic research, right?
Right.
The insights gained from Balrog can inform the development of real world AI applications, making them more robust, more adaptable, and ultimately more capable.
I'm already thinking about the implications for areas like, robotics, self-driving cars, even, personalized education or healthcare.
Yeah.
Imagine AI systems that can truly understand their environment, learn from their experiences, and make decisions that benefit humans in meaningful ways.
That's the ultimate goal, isn't it? To create AI that not only performs tasks but understands the why behind those tasks,
Yeah.
that can reason, that can adapt, and that can collaborate with humans in a way that's both beneficial and safe.
It's an ambitious goal, but Balrog shows us that,
Yeah.
it's not out of reach. By honestly assessing, the limitations of current AI systems, and embracing the challenges, we can pave the way for a future where AI truly, lives up to its potential.
I think that's a perfect note to end our deep dive on.
To all our listeners out there, keep pushing the boundaries, keep asking the cumulus the tough questions, and keep believing in the power of AI to make a positive impact on the world. Until next time.